Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we have question 8. It says the sketch below represents the function f of x is equals to x cubed plus bx squared plus cx plus d, and g of x is equals to ax plus q, right? The points A and then also B, which is given as 2 is to negative 16, and C are points where the two graphs intersect. C has the coordinate 6 is to 0, which is an x-intercept of f. You can see it here. And then while L and M are the turning points of f. So the local maximum and the local minimum point, right? Then 8.1 says, show that B is equals to negative 5, C is equals to negative 8, and D is equals to 12. If it is given that f prime x is equals to 3x squared minus 10x minus 8, right? Now, how do you solve this one here? Remember, you are given f of x here is equals to x cubed plus bx squared plus cx plus d. But then you are already told that the derivative is giving f prime x is equals to 3x squared and then minus 10x then minus 8. Now what we can do in order to calculate that is to derive what we have up here along with the variables that we have, the unknowns. So that's f prime x, that's 3x squared, and then this one, if we derive it, is going to be positive 2bx, and then here we'll only be left with c. But then why are we doing that? So that we can see that these ones are actually corresponding to each other, and this ones here is corresponding to that, and the c here is corresponding to that negative 8. So that means in calculating my value for b, I can just simply say this is 2bx and then equate it to that negative 10x. Then at this point, I would have to write this one as 2x and then times b, negative 10x. So that means I can divide by 2x both sides, and then that will leave me with b is equals to negative 5. But then looking at this one, we can see that the c just corresponds to that negative 8. So the c is just equals to negative 8. Now at this point, we can see that we got our b, we got as well our c, but then how are we going to get d? Right. Now with D, we can say that we cannot get it from deriving this, because as soon as you derive, the D is now lost because it's a constant. So that means we can only find the coordinate of D by using the original equation of f of x. So now we have f of x is equals to x cubed. Let's now substitute the B with negative 5. Then we have negative 5 squared, and then the c is negative 8. So that's negative 8x, then plus d. But then you will note that we do have the coordinates there for b. Also, we have the coordinates for c, right? So it can just be a matter of which coordinates we would like to use so that we find our value for d. Now we can go ahead and say, let's use these ones here, which are 6 is to 0. So that means where there's f of x, I'll just put 0 and then start to substitute in here. So that's 6 cubed minus 5. And then where there's x, I put 6 and then square, and then 8 multiplied by 6, then plus d. Right. Now, when I punch all this into my calculator, I find that my value is negative 12. So negative 12 plus d, that's going to give me 12 is equals to positive, d is equals to positive 12, right? And then that's how I was just supposed to calculate that one, right? Then now we can say that I have the value for a, which is, it's given already, it's 3. And then we have the value for b is negative 5, and then we have the value for c, it's negative 8, and then as well as the value for d, which is positive 12. Right. Then 8.2, let's proceed. Now they asking us to determine the coordinates of the turning points. Remember, your turning points are the stationary points, the local maximum and the local minimum, L and M of a graph F, right? So remember, we said that whenever we want to calculate the coordinates of the turning point, the first thing that we have to do is obviously find our derivative, but then there's no need to do that because we've already been given the equation of the derivative function. So we're just going to copy it like that. Then that's 3x squared minus 10x and then minus 8. Now we know that f prime x should be equals to 0 at the stationary points. So at stationary points, we know that our derivative function is equated to 0, right? So that means we take this equation here, 3x squared minus 10x minus 8, and then we equate it to 0. Then we try to factorize here. This will be 3x, and then plus 2, and then here we will have x minus 4. Right, so that's equal to 0. And then if we calculate this one, this is going to be x is equals to negative 2 over 3, or x is equals to positive 4. Right, so in order to find the y coordinates of the turning point, because remember they said the coordinates, so that means they are looking for the x coordinate and the y coordinate. So to find the y coordinate, remember, we go back to the original equation, right? So this is where we're going to substitute our negative 2 over 3 in the original equation. So where there is x, I'm going to replace with negative 2 over 3, and then that's cube, and then followed by minus 5. Remember our equation that we got, and then negative 2 over 3, and then square, followed by negative 8, and then here we have negative 2 over 3, then plus 12. Now, when you punch all that into your calculator, you get your value as 400 over 27, meaning that your coordinates for L are negative 2 over 3 is to 400 over 27, right? But then that's not the only coordinate that we have. We also have x is equals to 4. So again, we're going to substitute into the original formula. So where there's x, we replace with 4. So we replace with 4 where there's x, and then there we go, then plus 12. So when you punch all that into your calculator, the value that you get is a negative 36. So your coordinates for M are 4 is to negative 36, which is the local minimum point. It makes sense for where it is in the Cartesian plane. So we have here, this is 4 is to negative 86, and then we have there, that's negative 2 over 3 is to 400 over 27. So that's how you find the equations of, that's how you find the equation, that's how you find the coordinates of the stationary points. Then, okay, let's proceed. Now we have 8.3. Now in 8.3, it says determine the equation of G, right? So we can see that G here is a straight line having the coordinates B and C, which would aid us in calculating the gradient. Remember, G is a straight line here. So we know the first thing that we have to find when we want to find the equation of the straight line is obviously the gradient. So we can calculate the gradient of line BC, and then by saying y2 minus y1 over x2 minus x1, right? Now at this point, we can, here remember we have 6 is to 0, so we can choose to make this one here our y2, so this will be 0 minus negative 16, and then here we will have 6 minus positive 2, so this is 6 divided by 4, which will give us 4. So the gradient for BC is 4. Now to find the equation of G, we would have to say y minus y1 is equals to mx minus x1, right? And then we go ahead and substitute any of the coordinates that we want. So we can go with the 6 is to 0. We can go with the 2 is to negative 16. So let's just change things and just go with the B here. So this will be y But then since our y value is negative 16, that's negative and negative, it will be positive 16. Our gradient is 4. And then here we have x, and then our x coordinate is 2. So this would have to be 4 times x, that's 4x. Then 4 times negative 2, that's negative 8. But if we take the 16 and transpose it over to this side, that's negative 8 minus 16. So this is going to give us 4x minus 24, right? And that's how you find your equation of the straight line G. Okay, and then let's proceed to 8.4. It says it is further given that the coordinates of point A are x is to negative 36. So here that means we do not know the x coordinate of point A, but then we do know the coordinate of the y coordinate of A, which is negative 36. Now they say determine the length of AM, but if you were to look at AM, we can see that AM there, A and M lie on the same straight line. You can just try to draw a straight line here. You can see that they are exactly at the same point. Now, they did not tell us that, but then we can clearly observe that, right? But then we do know the coordinates of M because we did calculate them. The coordinates of M, remember, from previously calculating there, we said there were 4 is to negative 36, which now proves to us that they are on the same straight line because look at this, they share the same y coordinate. So they lie within the same horizontal line. So that means in order to determine the length between A and M, what we will need to check is the x coordinate of A here so that we are able to check the length because the length is horizontal. Therefore, the length can only be determined by the x coordinate, right? But then how can we find the value of x there? That's very simple. We have already came up with the line, the equation of the line G. So remember, G of x is 4x minus 24. But then we already have the coordinates of A, that's x is to negative 36. So where there is G of x, we can just say negative 36 and then try to calculate the value of x. So we will find the x value for when y is negative 36. So we can just say negative 36 plus 24 is equals to 4x, right? And then when you do your maths there, that's going to give you a negative 12 is equals to 4x. Then obviously dividing by 4 both sides, then your x is equals to negative 3. Then now, what is the length between AM? It takes 3 units to move here to get to the point of origin or the x-axis. So that's 3 units. So starting from this point all the way to point A, that's 3 units to the left. And then starting from the origin all the way to point M, that's 4 units. So now what is the distance between A to M? That's the 3 units and the 4 units. So that means we can just say that's 3 plus 4, which will give us what? 7 units. So the distance between A to M is 7 units. Okay, cool. Then let's go to 8.5. It says, for which values of x is the graph of f increasing? Now remember, we said whenever they ask us about increasing, decreasing, what we should always reference upon is the stationary points, the turning points. Because remember, a graph can either increase to a certain stationary point or decrease from a certain stationary point to another stationary point. So remember, our x coordinates, because we'll be determining the values of x. So we are only concerned about the x coordinate. The x coordinate for L was negative 2 over 3, but the x coordinate for M was positive 4. Now we want to find out where is the graph of f increasing, right? So where is the graph of f increasing? Now I want you to observe this. Bring your eyes over here. Bring your eyes over here, and then let's observe. What is your graph doing there? What is your cubic graph doing there? We can see that your cubic graph is increasing at that point. So for all the points, where your x is below -2/3. So before -2/3. So for all the x values that are going that side, for all the x values that are going to the left of -2/3, we can see that what is happening to your cubic graph, it is increasing, right? But then that's not the only place where we observe that. If again you can bring your eyes over here, let's check. What is happening again here? We can see that your cubic graph is increasing again, right? So it's increasing at the point where now your x values are above +4. So for all the x values that follow after +4, we can see that your cubic graph is increasing. So how are we going to write that? So for 8.5.1, we can say when x is less than -2/3, meaning for all the values that are going that side, and then also as well, or when x is greater than +4. Now it's a matter of the notation that you want to use. If you are comfortable with this one, you'll say when x is an element of -infinity all the way to -2/3, or x is an element of +4 all the way to +infinity, right? So this is where we find our graph increasing. Now you can ask, why am I not including the -2/3 and the 4? Remember, at -2/3, the graph is not increasing or decreasing. It is simply stationary. Hence, we say these ones are stationary points. So at this point, your graph is not increasing or decreasing. It's simply just stationary. The gradient is 0 there. So everything is just horizontally there. Okay, then let's go to 8.5.2. So now they say, is the graph for which values of x is the graph f concave down, right? So now it's asking about concavity. We know that in order to report about concavity, we have to find the point of inflection. Remember what we said? There is no concavity without the point of inflection. But then remember, I taught you a very easier way to find the point of inflection. I just said take the x coordinates of the stationary point. So when you take the x coordinate of the stationary point and calculate the midpoint between them, then you have your point of inflection. So you just go x is equals to -2/3 and then plus 4 and then divided that by 2. So we take the x coordinates of the stationary points, add them together and divide by 2. That's our point of inflection. And then what do we find? We find that our value is x is equals to 5/3. Now, if you don't prefer this one, there's also another method. You can do the second derivative and equate it to 0 and therefore find your x value there. Or you can go with the one that we said is x is equals to -b/3a using your cubic function, right? So either way, you will find your point of inflection as that. And then now, once you find your point of inflection, that's not your final answer. Remember, they just asked you, they just asked you, where's the graph of f concave down? So what is concave down? Let's understand. Concave down is when your graph is a frowning graph like this. So when it does a shape like this, we say it is concave down. So where in the graph do we find that shape? So if we have to predict that the 5/3 is maybe somewhere there, where do we find so let's say this is our point of inflection, 5/3, right? And then where do we find our shape being like this on the graph? Is it before the point of inflection or after the point of inflection? And then as we can clearly see there, we can tell that that is happening just before the point of inflection. So if you can just bring your eyes here, we can see that the shape concave down is here just before the point of inflection. So mathematically, how are we supposed to write that? We are supposed to say the graph of f is concave down when x is less than 5/3. And that's your solution, right? So that's how you were supposed to tackle this question for a total of 19 marks. So make sure that you play the video as many times as possible. and try to understand the approach that I took into solving this question. But with all that being said, please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.